So hello all, in this video we will see Rice's theorem, the statement of Rice's theorem. It actually deals with properties of languages and decidability of Turing machines regarding those properties. I'll give you the problem statement of Rice's theorem. Before that, I'll introduce you the basic concepts in relation with Rice's theorem. See, a property is nothing but a set of languages that a Turing machine satisfies. It's actually the subset of languages or subset of language. For example, the languages having the string, languages having substring or string 10. This is actually a property, that is, if the language of a particular Turing machine has the string 10, that is actually a property. For example, an empty language, that is another property. If a Turing machine accepts empty language, that's a property of a Turing machine. So property is nothing but a set of languages or a language that a particular Turing machine accepts or not. Or it can even be the set of it is a particular language or languages the set of Turing machine can accept or reject. So for example, languages having string 10 or languages with 10 strings, like this. So if some Turing machines have languages with 10 strings, they are said to have this property. Or if the Turing machine accept empty language, the Turing machine is said to have this property. Of the Turing machines, some Turing machines are having languages with string 10. They have said to have they are said to have this property. It's like that. So property is actually a set of languages or specialty of languages. Okay. Now there are trivial properties and non-trivial properties. Trivial and non-trivial property. See, trivial property is a property which every Turing machine and the universe hold or doesn't hold altogether. That is, if a property is actually trivial if it is held by all the Turing machine. For example, for all the Turing machine, the language is actually an element of sigma star, isn't it? Language is an element of sigma star. That is, we are creating the language, from the strings obtained by the different combination of alphabets, different combination of symbols in the alphabet, isn't it? For example, if A comma B are present in the alphabet, some combination of A comma B will be language will be taken from this, isn't it? So that's a trivial property, isn't it? That is, language will be having language will be a set of sigma star, containing subset of sigma star. Language will be a subset of sigma star. Language will be, yeah, that is a trivial property, because for every Turing machine, its language is made up of symbols from the alphabet, isn't it? So that is a trivial property. Non-trivial property are properties which some Turing machine satisfy and at the same time some other Turing machine do not satisfy. For example, languages having string 10. All the Turing machines will not have a string 10 in their language. For example, if the Turing machine is alphabet is containing symbols A comma B, definitely they are not going to have this string 10 in their language, isn't it? And some Turing machines will not take empty language, and some Turing machines will have 10 strings in their language, and some have more than that, or some have even less than that. So these are the properties which are examples of non-trivial properties, because some Turing machines will be having these properties and some other Turing machines will not have that property. Is it clear? So that is non-trivial properties. So Rice's theorem deals with non-trivial properties. So the statement of Rice's theorem is that is, if you are having a Turing machine, or can you construct a Turing machine which takes a description of another machine and decide whether a language N has a property P or not. That is, you will be having a Turing machine T and to the Turing machine, the question is, can you construct a Turing machine T such that when you are giving an input n to the Turing machine, whether this language n have the property P or not, whether you can construct a Turing machine T which decides on which can correctly decide whether the language n has the property P or not when you are inputting a language n or another description of another machine n. So this actually depends on the property P. If this property P is a trivial property, that is all the Turing machine either have this property or none of the Turing machine in the universe have this property, in that case this can be decided. The Turing machine can say an yes or no answer and hold. But if the property is non-trivial, that is some Turing machine have the property and some Turing machine does not have this property, some Turing machine do not have this property, in that case this is undecidable. You cannot construct a Turing machine which can clearly say and hold whether the description of another machine n or the language n has the property P or not. So that is the statement of Rice's theorem. Hope you understood. Thank you.